turbines of high output, say above 100 megawatts, it becomes physically difficult to make the cylinder large enough to accommodate all of the low-pressure steam. To get over this problem, multi-cylinder arrangements are used, and let's look at some of these arrangements. Here we see a common arrangement of two cylinders which may be used for units of up to about 150 megawatts. Crossover pipes are used to connect the exhaust from the high-pressure cylinder to the inlet of the low-pressure cylinder. Most low-pressure cylinders are of the double flow type, where steam enters at the center and flows outwards in opposite directions. This provides some balance to the thrust and tends to keep the shaft centered. As the steam path of the high-pressure and low-pressure cylinders is in series, all of the control is carried out at the steam inlet admission valves at the high-pressure end. The next development from this two-cylinder arrangement introduces reheat and the addition of the intermediate pressure stage of the turbine. A very common arrangement for reheat turbines up to about 250 megawatts is shown here. The high-pressure and intermediate pressure cylinders are combined in one casing. But of course, the steam path is quite separate. Note that the concept of counterflow is also used here, with the steam flowing through the high-pressure cylinder in the opposite direction to that of the intermediate pressure cylinder to help produce a balanced thrust. As turbines become bigger and bigger, it is necessary to add yet further cylinders, and the arrangement shown here is typical for machines in the 500 to 600 megawatt range. As you can see, we have separate high pressure and intermediate pressure cylinders, and also it has become necessary to add a further low pressure cylinder in order to handle the high volume of steam. With all of the configurations shown, the general control of steam flow through the turbine is achieved by adjusting the admission valves at the high-pressure inlet. However, note that with reheat units, additional control valves, known as intercept valves, are fitted at the inlet to the intermediate pressure cylinder for protection purposes. We'll be discussing this in detail when we look at control and protection in the next module in this series. Yet another cylinder arrangement used on earlier reheat machines is known as the cross-compound system, shown here. It really consists of two separate turbines, each coupled to their own generator, but interlocked through a common steam system. The high-pressure and intermediate pressure cylinders drive one generator, while the two low-pressure cylinders drive the other. Again, the steam flow through the combined turbine is controlled at the high-pressure inlet, thus controlling the output of both generators. Of course, the large reheat units that we have been considering would typically be found in central power stations of large utility companies. More recent installations, particularly in industrial situations, are likely to be smaller units, probably within the range of 60 to 150 megawatts. In order to examine some of the basic construction features, let's take a look at this single-cylinder machine. Steam is applied to the steam chest from the boiler after passing through the turbine stop valve. The amount of steam passing through the turbine is regulated by adjustment of steam admission valves. This in turn controls the output of the turbine and the coupled generator. At various stages along the steam path, steam is extracted from the turbine. This extraction steam is commonly used for feed water heating, but there may be other applications as well. The concept is that the extracted steam is put to good use after performing some work in the turbine. You will remember that we discussed this in the first tape in this series when we looked at efficiency. The turbine is supported on journal bearings, which